Hello everyone, and welcome back to another video. I'm gonna do a new topic because right now I am not at home, so I don't have my laptop with me. I can't do any leak codes right now. Well, actually, maybe I can on my iPad, but I just decided why not, let's just do like a new topic. And so after learning stacks and queues, the best option would be either like the hash table or hash table or trees. But I think hash table might be a little bit easier to just learn like real quick before we move on to like trees, so like the binary trees. And this is like the next most practical structure after stacks and queues, because it not only does it show up in tons of LeetCode problems, but like it's also conceptually simpler than trees and graphs. It also lets you introduce like the average big O of 1 lookups and like frequency countings and other stuff like that. So what we're doing is basically hash table. And since I wrote everything in Java, what I would just be showing you is HashMap and HashSet. So far we've worked with arrays and list. They're great if you want to access things like index, like for example array 0 or like array 5. But what if I want to look up things by something more meaningful than an index? For example, let's say if I were to given a student ID, can you quickly get the student's name? Or like given a word, quickly get how many times it appears. Or like another example, given a number, quickly check if we've seen it before. So doing that with arrays or lists is annoying and slow because you have to scan it linearly. And that's why this is where hash table comes in. And in Java, that's HashMap and HashSet. So let me erase real quick. So the basic idea of a hash map is it's sort of like a dictionary or like a phone. Think of it as like a phone book. You have a key and a value. The key is the thing you use to look stuff up, like a name or ID, right? So name or ID, and then with value, that's the data you want back. So like a score, an object, whatever. You don't care about the index position anymore. What you care about is, say, given this key, just give me the value very fast. So with a hash map, you can say, let's say like, I want to store like Alice has scored 90. So like a test score here. Now quickly tell me what Alice's score is. And under the hood, that lookup is basically big O of 1 on average, and it's constant, so constant time. Doesn't matter if you have like 10 entries or 10 million, it's gonna roughly the same cost. So in a way, you can kind of say the hash map is equal to key to value mapping. Keys must be unique and values can repeat. Okay, so let's talk about HashSet. A HashSet is like a hash map, but it only cares about keys, no extra values. It's just like a collections of unique items. So in a way, a perfect question would be like, have I seen this number? Or does this word exist in my dictionary? I have a list of duplicates. Give me only unique elements. So in a way, the rules would just be, if you need to map a key to some data, use HashMap. However, if you only care whether something exists or not, use HashSet. Okay? So map a key to data. that's just hash map. Only whether it exists or not. That's HashSet. So keep in mind these two are two different things. Now, I would say like a rough idea of how a hash table works is, let's say inside it has an array of buckets. You never see this directly. When you give it a key, like the string Alice, it first runs a hash function on the key. So hash function, or usually you can just write it like this, but I'm gonna write the whole. Actually, yeah, I'm gonna write the whole thing out. So hash function. So it runs a hash function on the key. That means take the key, turn it into some big number, the hash code. So the hash code is just any big number. It can be like whatever it is, whatever number is here. Afterward, it then uses that number to pick an index in the internal array. So, and I'll draw the thing out later. So, but right for now, I'll just explain it. Think something like hash value module array size gives you an index like 0, 5, 12, etc. And then 3 afterward, it stores your keys and value in that bucket. So next time you ask for Alice, it does the same hash, jumps straight to that bucket and finds the value. That's why lookups feels like a big O of 1. It's not searching the whole thing. It's jumping directly to where it expects that key to be. Now, let's say, for example, what if two different keys end up at the same spot? So, let's say we have Alice and Bob, and they both happen to hash to the same index. That's called a collision. So, collision. And hash tables handles this by letting each bucket hold multiple entries, often in like a small linked list or tree. So a bucket is basically sometimes empty, sometimes hold one entry, like one data, stuff like that. And then sometimes it can hold like a tiny list of small entries or data. So it can go up to 2, 3, 4, 5, any of that. Just a small tiny of that. And then when you look up a key, it jumps to the right bucket using the hash, then just checks the few entries in that bucket to find the exact key. So as long as the hash function is good and the table isn't overloaded, each bucket stays small. So it still feels big O of 1 time. So big O of 1 time. So why is HashMap or like HashSet, why are they good? In a way, obviously, number one, the speed on average. So right here, so speed on average, insert is big O of 1, lookup big O of 1. If you want to delete, that's also big O of 1. That's really good compared to when you just scan a whole list, which is usually big O of n. So yeah, like that. Another good thing about it is like it so it cleans APIs for common tasks. Now, if you know what API is, it would make sense. But if you don't, I'll make a new video about it in the future. But basically, HashMap count how many times this thing appears, or like map IDs to objects. For HashSet, it checks if I've seen this before, and it removes duplicates. So cleans APIs for common tasks. And then obviously the last, I guess another good reason would be like, they're basically everywhere in coding interviews. I think the first LeetCode problem, it has to do something with HashMap. So You've seen there will be a lot of LeetCode problems that are on this. So, and then these data structures are basically your default tools anytime you think of like, hey, I need to quickly look things up by key, or I need to know if this thing exists or not. And now with the time and space complexity, on paper, average case is big O of 1 again for add, remove, lookup. Worst case would be big O of n. So worst case scenario, which is crazy, would be big O of n. If everything goes into the same bucket, which is rare on its own, so that's rare with like good hashing and resizing, but it's the theoretical like worst case. And then like memory wise, HashMap and HashSet use extra space to keep the array of buckets and entries. So you're basically trading some memory for speed. Let's see, when is it not a good time to use like HashMap and HashSet? Yeah. So HashMap, HashSet. Actually, I'm just gonna write HashMap as HM and HS for HashSet. So, okay. So in a way, it's like if you need a sorted collection, like give me elements in increasing order. HashMap or HashSet are not automatically sorted. Other things would be like if you need to answer questions like give me the smallest k element or give me everything between 10 and 20. Hash table doesn't help directly. You will want to like see a tree structure or heap for that. And heap is another topic on its own. So I'll just write it out. They don't preserve order in HashMap, HashSet. If you need insertion orders, you use something like link HashMap instead. So the rule is if you care about fast, existent, or key-based lookup, again, HM, HS. If you care about order, range, or sorted data, other structures like tree, heaps, and sorted array are definitely better. Now, keep in mind, Java just calls the common implementation HashMap, HashSet. Other languages have the same idea but with different names. Python would be dic for dictionary and set. So dic would be the HashMap, and then set would be the HashSet. I think JavaScript is just plain object. So this one right here, often used like a hash map basically. So it would just be map key into value, and then set would just be like hash set. I don't know about C++, C#, any of that. Okay, that's basically it. And now I'll just write out like I'll draw it out basically. So for example, when I mention array of buckets, let's draw out the array first. And let's have 0 to 5. 0, 1, 2, 3, 4, 5. So, and then we'll label this as like a internal array of buckets. Now, we want to, let's write out some key and value examples. So again, let's use the scoring system. So we have Alice, who scored a 90. We have Bob, who scored a 75. And let's say like Charlie, who scored an 88. Now we can basically we want to draw the hash function. Between the keys and the array, draw a box labeled hash and then arrow. So Alice, arrow, the hash function, or like that, arrow again, and then index, say like index 2. Let's have Bob with the same thing, hash function, and then let's give it like index 4. And then I did previously mention like what if there's two in the same. So let's give Charlie the same as Alice, right? So Charlie will also, when it does the hash function, it'll also go to index 2. Now you want to show arrows from keys to buckets. So again, this is the bucket that I drew out, but I'm gonna draw it like this actually. It's slightly better to write out. We have 0, 1, 2, 3, 4, 5. Now there's nothing for 0, 1, 3, and 5. However, for 2 and 4, these are where we put in the keys to buckets. So with 2, we have Alice with 90. And, I'll draw parentheses, an arrow, then Charlie, who scored an 88, then in parentheses, and then no. So kind of, when you look at this, it kind of looks like a linked list. And then for Bob, who's by himself, with 75? Yeah, 75. Then with that, and then you point that to no as well. So each index of the array is a bucket. So bucket 2 has a collision. Both Alice and Charlie ended up in the same bucket. So we store them as a tiny linked list. Bucket 4 only has Bob. So we don't search the whole map. We hash the key, jump straight to one bucket, and only look at the few entries inside that bucket. Now HashTable, or sorry, not HashTable, HashSet, is something slightly different. So let's say value we insert into the set. And we have 10, 22, 31, 4. And then the array, 0, 1, 2, 3, 4, and then like 5 or something, I don't know why I drew it big, but let's say 31's here, points to null. 22 is here, points to null. 4 is here, points to null. And 10 is on index 5, and it points to null. Okay, so each bucket stores unique elements. When we call, when we call it, let's call it like contains, and then we want to call 22, right? We hash 22, jump straight to its bucket, and then check the tiny chain there. And that's it. That's really it. Let's see. To summarize how lookup works, right? We can draw like a simple flow. So back to here, we have key, where it's Alice. Hash key. And then another arrow, bucket index. So for example, the index we have was 2. So 2 here. And then you check entries in bucket 2, which, will have Alice 90, arrow key, Charlie 88. So key goes into a hash function, hash maps to an index. We jump to that bucket, then we just compare within that small list. And that's basically it. So I hope it's somewhat understandable with HashMap and HashSet. If anyone doesn't understand, I can try to, answer questions make another video and just answer it or something. But yeah, this is basically it for the hash map and hash set. Thanks for watching.